enter him, but right now we will start our lecture. Okay, so I have shared the screen, and today the article which we are going to discuss is about the temperature and heat, and it is all your today lecture is all about your previous concepts, and in these concepts what we will do is okay, we will just revise them, and later on then the problems related to these concepts we will solve them. Okay, so up to the last lecture everything was clear. A couple of students asked some questions, so they were satisfied or they want to discuss more right now.
Sir, it's clear.
Clear? Any question from previous articles? Anyone? If they have the questions, it's good to again Ali Sajid Jatt entering by his name. Okay, so what is temperature? We will discuss about the temperature. Previously, we discussed that temperature is basically the average kinetic energy of the atom. So then what is heat? How we can define the heat?
Transfer of energy.
And transfer of energy, obviously. Okay, when you have two objects like here, they have given us the example of the cola cane. Let's suppose if you are pulling it out from the fridge or the refrigerator. So what will happen that you will place it after some times, you will see that its temperature increased up to the atmospheric temperature. Okay, so it means that its temperature is rising and it is getting energy from somewhere. So from where it is getting the energy? Why its temperature is rising? Why from where it is getting the energy? Atmosphere. It is just like that. Obviously surroundings. Okay, the question is relevant question hai. Okay, normally what we have seen that whenever you have a fresh water from the well or from the river, you will see that in the summer it is cold, while in the winters it is warm. Why is it so? A normal question hai. It is our common observation that in summer the water of a river is cold, while in the winter it is warm. Why is it so? Anyone?
So due to temperature difference. Summer में sir water ज़्यादा heat absorb करता है, while winter में कम करते हैं.
तो विंटर में तो फिर वाटर जो है वो कोल्ड होना चाहिए रादर देन हॉट होने के या वार्म होने के.
Sir, वो specific heat of water.
सर evaporation की वजह से भी हो सकता है.
नहीं, evaporation, let's suppose in winter there is a temperature of 10 degrees centigrade.
Sir,
so
sir.
जी जी.
सर समर में होता है कि वो वाटर हीट एब्जॉर्ब कर लेता है और वही हीट जो है विंटर में वो रेडिएट करता है, इसलिए कोल्ड नहीं रहता, वार्म मतलब नॉर्मल टेम्परेचर.
अच्छा, इफ इट इज तो अगर फ्लो कर रहा है पानी तो वो पानी तो अपनी जगह पे ना रहा.
यस सर.
सर
जी बेटा.
सर ये हीट भी तो ठंडा या गर्म होना पानी का वो भी तो हम ही एब्जॉर्ब कर रहे हैं. जैसे गर्मी है तो हमें बाहर गर्म महसूस हो रहा है, तो जब पानी में हाथ डालेंगे तो वो हमें ठंडा लगेगा क्योंकि उसका टेम्परेचर उसके कंपैरेटिव में कम है.
Maybe some sort. Why its temperature is lesser? This is what my question is.
सर evaporation नहीं होगी. Means अगर गर्मियों में हम देखेंगे तो
evaporation. What is the vaporization temperature of the water?
सर वो heat absorb करेगा और उसके रिजल्ट में जो
सर evaporation हर टेम्परेचर पे होती है.
temperature पे है, the boiling point of the water is almost
100 degrees Celsius.
100 degree. So if you want to evaporate this amount of the water, you need 100 degrees centigrade. To some extent, मतलब ये होता है कि lesser amount can be evaporated, but major amount of the water cannot be evaporated like this. Okay, so it's not like that. The answer is quite simple. Okay, the temperature of the water is constant both in summers and that in the winters. Okay, because the temperature of the earth is almost constant. So basically what happens that in summer the outer atmospheric temperature is higher than the temperature of the water. Okay, let's suppose if the temperature of the water is 20 degrees centigrade, okay, or if it is 20 degrees centigrade, it will remain almost 20 degrees centigrade in summer and in that of the winter. But if the atmospheric temperature is 30 degrees centigrade or 40 degrees centigrade in summer, so it will feel colder in summer. While in winters, we have a temperature of about 10 degrees centigrade, 15 degrees centigrade, or 5 degrees centigrade, while the temperature of the water is the 20 degrees centigrade, so it will feel warmer compared to the atmosphere. So this is the basic reason behind this one. Okay.
Yes, sir.
Clear? Again, I am repeating this concept कि it is not like कि आप ये करें कि आप किसी ग्लेशियर के पास चले जाएं, then obviously there will the temperature of the water will be much lesser compared to the normal temperature. But when it is in the you can say कि plain areas like here in Gujarat or here in Lahore, Ravi, we are talking about the Ravi. Okay, in these regions, basically, it has almost same temperature in summer and that of the winters. Okay, so atmospheric temperature plays the role. If the atmospheric temperature is higher, the water will feel colder. If the atmospheric temperature is low, the water will feel warmer. Okay, so again, in the normal case, when you usually dig up the soil in the summer, it will feel cooler at the when you will dig up the soil. Okay, but in the winter, it will feel warmer. I am not talking about the surface. I am talking about that when you will dig it up. Okay, so in that scenario, your atmospheric temperature is basically playing the role. So same is the case here. When you are pulling out some cold fruit or a vegetable or can of cola from the refrigerator, it has lesser temperature, while the atmospheric temperature is higher. So after some times, according to the zero law, that when you have two bodies, obviously they will come into when they will come into contact, what will happen? They will reach to an equilibrium point. So when you will place the can of cola uh, on the table out of the fridge, so atmosphere has the higher temperature while the can of cola has the lower temperature. So energy will transfer from the atmosphere toward the can of cola. So its temperature will rise. Same is the case when you are pulling out some hot object from the microwave oven or the cooking range or from the stove. So what will happen now? The temperature of the uh, object that you have taken from the stove or microwave oven, it is higher compared to the atmosphere. So it will release energy from the atmosphere. It will release the energy to the atmosphere. Okay, so this is how it works. So this is the amount of energy that is released from the body to the atmosphere or absorbed from the atmosphere by the body is known as the heat. This is the amount of energy that is transferred either from the atmosphere to the system or from the system to the atmosphere. So in generalizing, normally when we generalize it, so the body that is under discussion is usually we call it as a system, while its surrounding is known as the uh, environment. Okay. In the case of can of cola is the subject that is under the discussion or that is under the observation. So we will call it as a system. While its surrounding, let's suppose we placed it on a table in a kitchen. So the atmosphere of the kitchen will be called as a environment. Okay. So these are the terms, two terms that we will use in our further discussion later on when we will study different articles like first law of thermodynamics and that of the second law of the thermodynamics. So these are the common nomenclature that we will use. Again, the body that is under observation or consideration is will be called as a system, while its surrounding will be called as a environment. Okay, up to this point, any question? किसी का कोई क्वेश्चन हो तो अभी पूछ सकता है. Okay, I think okay. Okay, so now we will move toward the next step. Okay, ठीक है. Up to this point they have studied about this one. ठीक है. So again, why it does happen? ठीक है. Heat क्यों ट्रांसफर हो जाती है? क्यों? क्या उसको क्या मौत पड़ी इक्विलिब्रियम अचीव करने की? कहने को तो हमने कह दिया. नेचर का रूल है हाई से. You are saying right.
नेचर का रूल है सर, जिधर हाई पोटेंशियल से लो पोटेंशियल रहती है, इस तरह हाई टेम्परेचर से लो टेम्परेचर में शिफ्ट होता है और इक्विलिब्रियम कंटेन हो जाता है.
लेकिन ठीक है, वो इट इज रूल ऑफ नेचर, बट व्हाई इन द केस ऑफ द हीट क्यों रूल क्यों ये अडॉप्ट कर रहा है? व्हाई डज इट वांट? कभी सोचा?
सर क्योंकि हाई टेम्परेचर स्टेबल नहीं होता.
नहीं, बेसिकली everybody in the universe wants to relax. ठीक है, they will always come to a relaxed state, everybody. ठीक है, so whenever there is a chance they will move toward a relaxed state. It is just like if you have a spring, you are pulling it or stretching it or compressing it. So when you will release the force, what will happen? It will go toward its normal state in the relaxed state. So when you have a hot body, so obviously the vibrations of the atom is larger. Okay, in the case of the hot body, because its temperature is higher. So again it will start colliding with the neighboring atoms and it will lose its energy because it wants to go toward the obviously relaxed state. ठीक है. So this is the main in the same case कि when you have a cold body, the atmosphere atoms have a high temperature. So obviously the atmospheric atoms will vibrate and they will transfer their energy toward the body that is at low temperature. So again, in this scenario, the atmosphere atoms want to relax. Okay, so this is how it works. So everybody in the universe want to go toward the relaxed state, and in this relaxed state is when you it will go toward the lower temperature. Okay, so it will lose its energy. So again there are जी
सर फिर जो जिनकी एनर्जी हाई है वो तो रिलैक्स स्टेट में चले गए नीचे हीट रिलीज करके, तो फिर दूसरों को क्या कसूर था? उन्होंने क्यों गेन कर लिया? अगर उनको फिर रिलैक्स स्टेट में जाना था तो उनकी एनर्जी तो पहले कम थी.
There is no mean कि आपकी total energy always remain conserved in the universe. ये पढ़ा हुआ है आपने, पढ़ा हुआ है ना, law of conservation of energy. ठीक है, energy cannot be destroyed. ठीक है, it can appear from one state to the other. In this scenario, the energy, let's suppose for the hot object, the energy transferred from the body toward the atmosphere. ठीक है, simple is that. ठीक है, energy transferred from the system to the environment. ठीक है. So again क्या है कि उनका कसूर कोई नहीं है, but again they were at lower temperature compared to the hot body. ठीक है. So the body, अब क्या हुआ है कि इस तरह ये होता है कि आप जब normally when you will deal these sort of the things, the energy cannot be destroyed. It has to appear somewhere. So in this case it appeared in this scenario. ठीक है.
जी सर.
चल ओके, अब अगेन नेक्स्ट क्वेश्चन आ जाता है कि when would be the Q positive, when we can take heat positive, and when we can take it negative. Heat is positive when energy is transferred to a system. ठीक है, let's suppose कि अगर आप cold can ले रहे हैं, cold body है, the energy is transferred from the environment to the cold body. So in that case, the system that has attained the energy, it will be called as a positive energy. ठीक है, positive heat. On the other hand, for a hot body, ठीक है, energy is transferred from the system to the environment. In that scenario, heat will be known as a negative. ठीक हो गया? He has given us some example here. This is a system here. Ts is the temperature of the system, and Te pink region is basically temperature of the pink region is environment. So just hold on a second. This pink region is the environment. This green color is the system. ठीक है, so in this case the temperature of the system is higher than the temperature of the environment. He has mentioned this one. So in this scenario, heat will be transferred from the system to the environment. So heat will be negative.
Negative.
Okay. Okay. Q less than 0 means that it is negative. Okay. In second case, this is the second case. In this case, the environment has the higher temperature compared to the system. Ts is less than Te. It means that system has the temperature less than the environment temperature. So in this scenario, energy will transfer from the environment to the system. So system has gained the energy. So we will take Q as a positive here. Q is greater than 0. After some times, let's suppose after some time, what happens that in the system and the environment are at the same temperature. Okay, so in this case, there will be no transfer of the energy. So we will take heat equal to 0. Okay, clear? Any question up to this point? Okay, fine. So I'm okay, good. बेटा आपकी आवाज बिल्कुल कट रही है. एनी क्वेश्चन? नहीं, ठीक है. अच्छा, व्हाट इज द यूनिट ऑफ द हीट? क्या होती है?
Joule.
जॉल. ओके ओके ओके, ठीक है. गुस्सा नहीं करना, गुस्सा नहीं करना बेटा, पता लग गया. गुस्सा नहीं करना ज्यादा. जब आप लोगों को चीज आ रही होती है ना, फिर आप लोग रुकते भी नहीं है फिर. अच्छा, एनी हाउ. अच्छा, एनी हाउ दी ओके, जॉल. व्हाट आर द अदर यूनिट्स? ठीक है, एक तो इट इज मेंशन्ड हियर क्लोरी, देन देयर इज अनदर यूनिट. वो कौन सा है?
ब्रिटिश थर्मल यूनिट.
ब्रिटिश थर्मल यूनिट कहाँ पे यूज हुआ होता है? कभी सुना है ब्रिटिश थर्मल यूनिट कहाँ पे यूज होता है?
अमेरिकन इंजीनियरिंग यूनिट है सर.
अमेरिकन इंजीनियरिंग सिस्टम है.
ओके, लेकिन आप
में यूज होता है सर.
हाँ,
18,000
यूनिट है.
बिल्कुल बिल्कुल. ये इसी तरह के बेसिकली नॉर्मली जो यूनिट बीटीयू हम लोग ऑब्जर्व करते हैं, इट इज के आप जो है एसीज एयर कंडीशंस के अंदर ये ब्रिटिश थर्मल यूनिट यूज करते हैं, जो हमारी डेली लाइफ में है. अच्छा, अब नॉर्मली क्या होता है? ओके, व्हेन वी वांट टू परचेज एन एसी, ठीक है, हम लोग क्या करते हैं? ओके जी, रूम इज स्मॉलर, so we will take a 1 ton AC. Agar if room is bigger, so we will buy or purchase an AC which has a capacity of 1.5 ton. ठीक है, ये कैसे आपको पता चलता है?
ये फिक्स वैल्यूज है.
Fixed value? How is it so? Well, I have a room of 10 by 12. So what sort of the AC I would like to purchase? Whether I would like to purchase 1 ton or I would like to purchase 1.5 ton or I should purchase 1.5 ton. How?
Sir, can you kindly repeat the question?
The question is, I have a room of 10 by 12 square feet. It is 120 square feet. So I want to purchase an AC. Okay. So which AC I should purchase? 1 ton or 1.5 ton?
सर जी आपकी बात है तो अंदाजा इतना हो गया कि 1.5 टन लेंगे
1.5 टन सर
इसका जवाब आप देंगे
अच्छा the interesting thing is basically when you want to purchase any sort of you have to calculate it with the room dimensions, even you have to consider the height of the room. ठीक है, so then there will come a point, ठीक है, calculations होती हैं, normal calculations होती हैं, we calculate those dimensions and after that we take, okay, we want to take 18,000 BTU, 15,000 BTU or something like that. So it all depends upon the units. अब मजे की बात ये है कि normally हम लोग क्या कंसिडर करते हैं, okay, 10 by 12 is a small room, okay, so 1 ton is fine to us. So 1 ton is not fine to us. For that case, 1.5 ton is fine to us. Okay, 10 by 12 by 14, 1.5 ton or sometimes 2 ton, it is fine. ठीक है, अब प्रॉब्लम कहाँ पे आती है कि बेसिकली वी यूजली सेव द मनी, ओके, बाय परचेजिंग द स्मॉलर एसी. ऑन द अदर एंड वी आर इंक्रीजिंग आवर इलेक्ट्रिसिटी बिल. ठीक है, इट इज जस्ट लाइक कि व्हेन यू आर टेकिंग द स्मॉल एसी, सो व्हाट इज हैपनिंग कि इट विल टेक मोर टाइम टू कूल डाउन द रूम. When you will take the bigger AC, it will take less time to cool the room. So as a result, in the case of the smaller AC, more electricity will be used compared to the bigger AC. So
सर ऊपर से कंप्रेसर के जलने का भी वो खतरा होता है.
On the other hand, यही है कि उसकी लाइफ बढ़ जाती है. When you are using the bigger AC, its life increases. मतलब every electronic object in the universe has certain life. If you are talking about the LED bulbs, we usually call, okay, life, how much hours, life hours it has. Sometimes it is 10,000 hours, sometimes it is 1,000 hours. So each and every electronic object has its service life. So when you are using more and more AC, so it means that you are decreasing its life. So with the passage of the life, its degradation also takes place. So at the start, new object takes less electricity, and when its life decreases, means the remaining life decreases, so it will use more and more energy. Okay. So these are the normal things, which we should consider normally purchasing the AC or other electronic objects, because if you want to use, you can save money on the one end, but you will be able to spend extra money on the other end, like in the electricity or its normal life. Okay, because you have to replace it early compared to the bigger AC. Anyhow, it was a irrelevant thing. So just came to my mind. I thought I should share with you. Okay, so calorie is initially calorie was the unit of the heat. So it is basically the amount of heat that is required to raise the temperature of 1 gram of a water by 1 Kelvin. Okay, that is 14.5 degrees, 1 Kelvin, sorry, 1 degree, 14.5 degree to 15.5 degree. In British system, the corresponding unit is British thermal unit. It is the amount of the energy that would be required to raise the 1 pound of a water from 63 Fahrenheit to 64 Fahrenheit. Again, in this scenario, 1 Fahrenheit, there will be a change of 1 Fahrenheit. But later on, afterwards, the scientific community, after 1948, the scientific community decided that it is better to use joule rather than BTU or chlori as a SI unit, because the reason is that the unit of energy is usually called is we call the unit of energy is joule, and in this case the energy is basically transferred from one body to the other. So it is better to utilize joule rather than BTU or the chlori. So one जो chloride is equal to 4.1868 joule exactly, and in the terms of British thermal unit it is 3.968 into 10 power minus 3 British thermal unit. Okay, fine. चलें, अब आ जाते हैं the absorption of the heat. अच्छा, up to this point any question from anyone? I think clear है. लाइक बच्चे हो आप लोग, अच्छी बात है यार, मुझे कम खपना पड़ेगा. ओके, नो कमिंग.
अल्हम्दुलिल्लाह
सर. अच्छा, चलो गुड है, अच्छी बात है भाई. ये है कि पेपरों में मुझे ज्यादा ना खपाना, ठीक है, फिर मैं बाद में ज्यादा खपा दूंगा आप लोगों को.
नहीं सर, मजाक.
अच्छा, एनी चलें आप अटेंडेंस थोड़ी सी ले लेते हैं, ठीक है
सर.
रोल जी.
सर ये जो 14.5 से 15.5 है, ये वैसे ही लिया गया या कोई वजह थी इसकी?
बेसिकली बेटा ये नॉर्मली जब भी आप स्टैंडर्ड इवन लेंथ की भी लेते हैं ना, उन्होंने सर्टेन कंडीशंस रखी होती हैं कि इस कंडीशन पे इस टेम्परेचर पे क्या होगा, इसका मैस इतना होगा, इसका इतना होगा. उस पॉइंट ऑफ व्यू से नॉर्मली आप लेंथ किसके बराबर है, 1 मीटर की एक सर्टेन आपने कह दिया 1 मीटर, बट इन एसआई यूनिट्स the basically the calibration of 1 meter is about there is a specific object, ठीक है, that is placed at somewhere at certain temperature and at that time its length is measured, ठीक है. सो इस तरह का होता है, certain इन्होंने लिया होता है, कोई रीजनिंग होती है इनकी sometimes ना. right now why they have taken 14.5 I don't know, ठीक है. मैं वैसे कहूँ कि अभी right now जो है वो क्या है, अगर जो है आप लोग लेते हैं, इट इज जस्ट लाइक कि जब आप हायर टेम्परेचर लेते हैं या लो टेम्परेचर लेते हैं, द एनर्जी डिफरेंस विद द एटमॉस्फेयर जो है वो अपना रोल प्ले करती है अमाउंट ऑफ एनर्जी ट्रांसफर्ड में, ठीक है. इफ यू हैव अ वेरी कोल्ड ऑब्जेक्ट, देयर आर टू ऑब्जेक्ट्स, ठीक है, वन हैज अ टेम्परेचर ऑफ 10 डिग्री सेंटीग्रेड, अदर हैज अ टेम्परेचर ऑफ 30 degree centigrade, and the atmosphere has a temperature of 50 degree centigrade. At the start, which body will transfer more energy, 10 degree centigrade or 30 degree centigrade? कौन सी बॉडी ज्यादा तेजी से हीट ट्रांसफर करेगी?
30.
No, 10. The heat transfer is totally dependent upon the temperature difference. Greater is the temperature difference, greater will be the amount of heat transferred, ठीक है. At the start it will transfer more and later on it will slow down, and eventually when it will reaches near the atmospheric temperature the amount of energy transfer is very slow, ठीक है. So it is just like that. अच्छा, section B है बेटा, roll number 2 present है?
Yes sir, present.
4
Present.
6
Present.
8
Present, sir.
10 12
Present.
Now the next article is about the absorption of heat by solids and liquids, ठीक है. So you already have studied the concept of heat capacity and that of the specific heat on the when your capacity and metric, I think. So what is basically heat capacity? And what is the difference between the heat capacity and that of the specific heat? क्या होता है? And can anyone define what is difference between the specific heat and that of the heat capacity? How do they differ and why do they differ? कोई भी नहीं?
सर स्पेसिफिक हीट तो 1 kg मैस की हीट होगी ना?
ऑब्वियसली बेटा, बेसिकली स्पेसिफिक हीट क्या है कि हीट कैपेसिटी पर यूनिट मैस, ठीक है. सो हीट कैपेसिटी पर यूनिट मैस फिर आवाज कट रही। अच्छा, अब बेहतर होगी आवाज?
यस सर।
यस सर।
हेलो, बीच में कट गई थी, अनस्टेबल आ रहा था इंटरनेट कनेक्शन। अच्छा, अब हीट कैपेसिटी को दे हैव मेंशन्ड इट एज लाइक ए प्रोपोर्शनलिटी कांस्टेंट है बिटवीन द objects that absorb or loses the heat. ठीक है, heat capacity we can define it as okay the amount of energy required to raise the temperature of a substance of any object through 1 Kelvin. Okay, while on the other hand specific heat is defined as the amount of energy required to raise the temperature of 1 kg of a substance by 1 Kelvin. Okay, this specific heat capacity can be defined as the ये इन्होंने दी हुई इक्वेशन फॉर द हीट एंड यू कैन सी एक सेकेंड बेटा बस। अच्छा जी, अब ये कोई एरो लगा रहा है, शो नेम्स ऑफ। ठीक है जी, मेरे से आज गलती हुई, आज मैंने मेंशन नहीं किया वो शो नेम्स ऑफ। ठीक है, बच गया इस दफा, नेक्स्ट टाइम नहीं बचेगा, दोबारा करेगा तो। अच्छा, अब ये कैसे आपने डिफाइन कर ली दी अमाउंट ऑफ एनर्जी रिक्वायर्ड टू रेज द टेम्परेचर ऑफ बाय 1 केल्विन। ठीक है, सो आपका यहाँ पे क्या आता है? C is basically C is the constant of proportionality, and I was telling you that the heat transferred or the energy transferred is directly dependent upon the temperature difference. So if I will remove this C here, so it shows me that Q is directly proportional to the delta T. ठीक है, it means that the energy transfer or the heat is directly proportional to the delta T, or I can write it as Q equal to C delta D, where C is the constant of proportionality. So you got it? कि क्यों आया? C is basically constant of proportionality, and when I will define the C, it would be like Q by delta T. Okay, so delta T is again the final temperature minus initial temperature. Okay, so क्या कहता है कि उसने एग्जांपल दी है एक स्लैब की कि आपका स्लैब के हीट कैपेसिटी C of a marble slab used in a bun warmer might be 179 calorie per degree centigrade, which we can also write as 179 calorie per Kelvin or as 749 joule per Kelvin. ठीक है, सो ये किसी भी हर मटेरियल की each and every material has its own heat capacity. ठीक है, one can absorb more, one can absorb less. You can take the example of the oil and that of the milk. So females are more used to this one. Which one takes more energy to get warmer or to get hotter, milk or oil?
Milk.
Absolutely oil.
Oil, no, oil need less energy, so it gets more warmer, it gets hotter quickly compared to the milk, because milk takes time to get boiled. Okay, so oil need less energy. In the same way, which one gets more cooler compared to the other? But when you have stopped the heating both of them, so which one get cooler around, which one reach the room temperature more quickly compared to the other? And in that
Milk.
case also oil. Oil. Milk can never reach quickly at the room temperature. ठीक है, because it has more heat capacity. So obviously when you need more energy to boil a body or to heat a body, obviously it needs more time to cool down. ठीक है, if one body needs more time to get absorb